Hello dear students, we are going to have a lesson in modern physics and we are going to look at the structure of an atom. An atom is the smallest electrically neutral particle of an element that can take part in a chemical reaction. Atom consists of three subatomic particles: protons, neutrons, and electrons, where we have the electrons orbiting around the nucleus, and protons and neutrons are inside the nucleus of an atom. Now we have some difference between the atomic number and mass number. Atomic number is the number of protons in the nucleus of an atom. We represent it with the symbol Z, and atomic mass is the number or is the sum of protons and neutrons in the nucleus of an atom. We can obtain the atomic mass by adding the atomic number plus the nucleon number or neutrons. So we have an isotope. We can define isotopes as atoms of the same elements with the same atomic number but different mass number. Isotopes can have the same protons and neutrons, but they will always have different neutrons. So we have some examples of isotopes like carbon-12, carbon-13 and carbon-14 are all isotopes of carbon. Chlorine is an isotope which includes chlorine-35 and chlorine-37. We also have uranium is also an isotope which includes uranium-236 and 232. We have a photoelectric emission, which is a process of ejecting electrons from a certain metal surface, for example zinc plate, when electromagnetic radiations of sufficient frequency fall on it. This normally occurs in phototubes and photocells. Photocells consist of cathode coated with photosensitive material and an anode. These are enclosed in a vacuum glass tube. The vacuum glass tube is evacuated in order to avoid collision of ejected electrons in the air or gas molecules, which would otherwise lead to low current. So we have a diagram there for the phototube, which shows that when light falls on a photoelectric surface, it will emit electrons. In so doing, current will flow in a circuit. As you see in our second diagram, we have some light incidented on a photoelectric surface, and there will be deflection at the emitter. So that's a phototube, and it's an example of photoelectric emission. So how does the phototube really work? Electromagnetic radiation are directed to the cathode and supply sufficient energy that causes the liberation of electrons. The electrons are then attracted to the anode and they produce current in the circuit, hence the emitter deflects. The flow of these electrons completes the circuit and hence electric current flows and causes the emitter to deflect. So that's how the phototube really works. When cathode rays fall on the photoelectric surface, they will liberate electrons which will flow around the circuit, hence conducting current. So we have some conditions for photoelectric effect to take place. We have the nature of the material or the metal. We normally use zinc sulfide as a photoelectric material because it can really emit electrons. We also have another condition, which is the frequency of the incident electromagnetic radiation. It should be noted that electrons are not emitted until a certain frequency called the threshold frequency is reached. Now we have a process which is called thermionic emission, which is a process whereby electrons are emitted from a metal surface by heating. The streams of electrons are transmitted or travel in a straight line and these streams are called cathode rays. So when you hit a metal surface, it will emit electrons, which are called cathode rays. So it gives us a definition of cathode rays from the previous examples. Cathode rays are streams of fast-moving electrons. We have a production of the cathode rays. Cathode rays are produced when you hit a metal surface with a very low PD across the filament. The cathode then emits electrons by the process which is thermionic emission. The emitted electrons are then accelerated by a high PD or high energy tension applied between the filament and the anode so that they move at a very high speed. This constitutes a cathode rays production. Properties of cathode rays. Cathode rays have several properties which may include they travel in a straight line. Being electrons, they are negatively charged. They are deflected by electric fields. They are also deflected towards the positive plate since they are negatively charged. They are deflected by magnetic fields. They also ionize air and gas molecules. They cause fluorescence of substance, e.g. zinc sulfide, and they darken photographic film. They also possess kinetic energy and momentum, and they can also be stopped by matter. So those are some of the properties of cathode rays. So we have an exercise which you should do. It will be an easy exercise. It involves some of the previous work we have just explained, and it will give you time to practice. Question 2 will involve obtaining the mass number. Given the mass number and neutrons, you'll be able to obtain the protons and electrons of that element. So we shall be waiting for the feedback. Thank you.